Good morning, Namaskar. Good morning, this is Suraj Singh speaking from Bharat. On this day, June 18, 2021, Friday, title being quality, gross title is quality, and role of engineers in quality, role of engineers everywhere, whatever is being done. Civil, field engineering, COVID-19, role, COVID-19 involvement in improvement or the improvement of life designs, construction methods, contracts, organizations, communication, coordination, quality, etc. etc. A little late today, but because of some reason it was. So we have to refer to again these certificates. We have to refer to certifications which are very important. These certificates tell something which you must comply by. You must prove that these certificates are real one and not fake one. These certificates tell people that this person is competent, but person must be competent. That's what I'm saying. It's not simply we have certificates and we are competent. We must prove that we are competent. Proving is important, not just all things say. Proving is very important. If we can't prove, means we are not that. That's very important point. So let's say quality. Yesterday I was talking about quality. Every day I'm talking about quality. Is very important for me. Maybe it's not important for everybody because everybody is not interested in quality. People are interested in quantity. In fact, people are interested in quantity, not in quality. But we should not forget that it's quality that is required everywhere, nothing else. If quality doesn't work, material doesn't work, product doesn't work, service doesn't work. We may pay whatever to someone for material, for goods, for services, but it doesn't mean highest price we pay that is quality material. This is misunderstanding. I can't say that. If I have price to some branded product, it doesn't mean that product project is quality one. It doesn't mean at all. And if I pay lower price, it doesn't mean that product is not of quality, good quality. It depends. Sometimes if you buy something from very low class vendor who may sit on footpath, on roadside, and I think always that, oh, this is low profile vendor sitting on footpath, what product he would give, means it's so cheap product he is selling. It cannot be quality product. That equation comes into my mind, but it's not true in every case. It's not true in every case. Sometimes what happened that product of such people, such vendors are bought by branded organizations, and they just put their own seal on that product or logo, and it's sold at many times price of what they buy. This means quality depends on individuals and not on brand. Yes, I'm not saying every brand is bad. Brand is brand, but it doesn't mean that brand gives you quality. It doesn't mean that, be clear. Brand can give you product, but it doesn't guarantee any quality. That's my argument. That's my sheer argument. Highest service provider gives you quality service. It doesn't mean. I have seen biggest service providers companies like many these days in mobile service, all of them. They don't provide good service. There are so many service defects in their services. Every defect. No need explain, no need include here. Those defects are correctable, but because they don't want to engage such people who can correct them, they want to save money. They don't want to spend more due to their restrictions, due to their budget, or due to their imbalance on your balance sheets. Whatever being reason, my issue is not that. My requirement is that quality must exist everywhere. Engineers must understand this point. Engineers from all branches of engineering, because people depend on engineers. If engineers do not exist, do not work in organizations, in factories, in industries, all industries would close, all construction would close. all development would close. Engineering, you can say, practically rules life requirements. Every product is somewhere, somehow, is linked to engineering input. Every product. You can count on and you will find there was some link to engineering, otherwise you could not see this product. So when such is case, keep aside commerce, keep aside profit, keep aside reputation, keep aside everything, but walk on quality. Walk with quality is very important from engineering viewpoint. Talk with quality, walk with quality, listen to quality, speak to quality, analyze with quality. Quality should be your friend. Quality should be your guide. Quality is your baby because it is you only, some engineer only, or a group of engineers only who decided specifications for implementation, who decide what should be done, how should be done, why it should be done, what is requirement, how can we meet that requirement. All those points, every question you raise, you will find answer in terms of some value, and that value means what way you want to use it. That specification of your use, that performance specification comes only from making specifications. If you produce some article, some good to that level, it shall definitely perform. There is no way it should not perform. But you can say it doesn't perform because of many reasons, because of negligence, because of ignorance, because of lack in supervision, because of no quality input or no proper input. You may say no one reason, many reasons. I'm not going to repeat those reasons because well, I have a little many times. I already represented many times those reasons. My only issue is quality is baby of every engineer, and quality must be respected by every engineer, every owner, and all requirement that we have to get from these materials must be defined before material is produced. We should not claim undue. And if quality doesn't exist, I can say present doesn't exist. In fact, existence means not physical existence, quality existing. I am existing physically, whether I am living in quality or not living in quality, that I have to see. An engineer has to realize these facts, and particularly a civil, electrical, mechanical work, basics engineers in products everywhere. They must realize the role of quality in our life. It's like a role. Quality has a role everywhere. And if quality cannot play its role, we are in wrong boat. We have to be clear about this. So I say I'm just going to our talk that we did, and that's why I say I talked about many items, many statements that are used in our life, that are required in our life. When we start some project, we take care of many things. When we start something, we take care of all items of that. We are taking example of certain projects, certain imaginary projects as real projects. What we think on that? We start with something when there is nothing. We can say we start with scratch, like we started drawing, we start with scratch. What is that scratch? That scratch is piece of land. We start with that. There's nothing, there's just nothing on that. There is only soil, natural stone, and unevenness of ground, natural grass, weeds, plants, rubbish. What we do? We clean all that. We have to prepare that land into a level from where we can start it. Or you may call it something unprepared, lying in nature, which you have to change to our requirement. So what we do for that? We do survey for that. Survey means we set out something. We set out controls from where we will use our controls, means we establish certain controls based on world controls, or you can say imaginary controls, or real controls, or hypothetical controls. When there was no GPS, we used to imagine something that this is our datum label, this is our datum line. We'll use for that, and that datum line labels or fixed on sites. But now because of GPS, we run from GPS, so it's internationalized, means we can use it from wherever we want, and we can take reference to GPS and establish that. And that's called process of setting out and excavations we have to do from that. Setting out is very important on every project, and that's why just setting out of human beings, setting out of individuals, setting out of work, setting out of requirements, setting out of everything, you can say here, setting out of sites, but I say setting out of your life. Actually you say right, setting out of quality, setting out of system, setting out of organization, setting out how to think, setting out how to produce, setting out how to decide depending on requirements, depending on how much you're going to spend on that. That's called budgeting. So budgeting is also kind of setting out that you're going to limit yourself in this financial arrangement you have to work out, and that's also very, very important point. Like should say setting out and excavation. Why it says combination? Because setting out is a start and excavation. Number one, physical activity. Setting out is not physical activity. Setting out is limitation. We have to work within this limitation. These are four cornerstones of our plot, our land, or better limit, I can say. We cannot go out of that. So like that, we can say excavation then started, and if setting out is erroneous, for example, setting out is erroneous, excavation shall certainly be erroneous. Therefore, setting out is very important. It is permanent basis for that project, not only during construction time, also post construction time. When project is delivered, the setting out still works for record purposes. But this was our datum from where we take labels, and this is our datum from where we took our coordinates, or you can say horizontal controls and vertical controls. We do that. Controls means generally there are two controls mainly. Means we have to control horizontally. We cannot go out of this line, we cannot go out of this label, and that's what we say. So you can say setting out. People say you make some settings in general, like they say make some setting with people, make something. They speak in different tone, different meaning. But here setting out means survey. You do survey. Process of setting out is surveying. Process of establishing some labels and some, you can say, benchmark or some coordination labels on site. Setting out, and that setting out is very accurate. We cannot contravene that. It's a kind of, I'm not saying about a statement, I'm saying construction of that, interpretation of that, how do we move. And then we come, we do complete survey, we record existing labels. That's all part of surveying. What labels are there? We may take photographs. Means these labels would be required for future references, because once excavation is done, those references cannot be known, cannot be seen. So prior to excavation, so many records are made, and those records can be used for future references. So pre-excavation activities are also many. You have to clear site, you have to remove grass, you have to remove plants and weeds, you have to remove garbage, you have to remove so much from there. You have to bring some machine and clear site. We have to fix boundaries of site. I mean to say something which is not going to be valued in terms of money, but in value in terms of starting of some project work. Then comes real work, which we say excavation. It could be machine excavation, it could be hand excavation, and excavation is very important part of project because it has no limit. Excavation, if it is a green project, is not that troubling because on green project we have to do a lot of site preparation. Green project means which is going to be exclusively new project where there exists nothing. And brown projects means where there exists something already and we are going to improve that project. So green project and brown project are different. I am talking about both. It may be green, it may be brown, and then excavation comes into play. You can say underground services come into play. In many projects there are underground services already running, and those services, because there is no other way, services shall run in ground, and there is no other way that we have to handle those services. If we know, we have to protect those services, we have to respect those services, and depending on contract conditions we have either to divert those services or to protect those services, or we have to deal with those owners owning these services and all those authorities who relate to them. We should know about where this is run, and that can be known from either owner of this area or authority who is responsible for those recording. And we should know that means here we are having that risk. This is called risk of services. If we break those services, if we do not respect those services, this may cause heavy problem. These services may break. For example, there may be electrical services, high voltage electrical services. There may be pressure water services. There may be, some other chemical services, gas services. There could be anything which can be damaged during excavation. That should not happen. That is nonsense, you can say. If you don't care about that, you have no right to break any service. So that is pre-excavation activity, which is very much technical and important. If you get information through those drawings which are available on record, and they are generally called record drawings or as-built drawings. These drawings must be respected very well. Now, how to know that? I have explained in many, but just briefly again. If there is nothing below that, that's okay, fine. We have to do site preparation, and on major projects, mega projects, meters of soil, meters depth of soil is filled in. We have to remove all loose soils from those areas and fill back with good soil, or you can say granular fill in layers, and that is called soil improvement as well as site preparation. Part of site preparation where services may not be that jeopardizing item. We are not jeopardized by those services if it is green project, but in brown projects there is always relation to that jeopardy, in which case we must know where services are and we have system to know that. Then we have to see indicatively services exist here, so we have to use method of hand excavation or manual excavation to know. Just we have to excavate small pit, maybe up to 1 meter or more, where we can expect the services run at, and we then see what to do with that after exposing that manually or by hydrojetting. If not, we can't excavate by tools. We can use hydrojetting. Maybe it is fiber optics or something. So very very soft service mechanism. Like that, we see this is means systematic work we have to do. Systematic work. We have to take care of everything before jumping onto conclusion that we can run fast Until we see are not clear, we can't run fast. And then excavations, it's not necessary with the excavation all time directly. There could be different types of foundations we are going to start with. It may be ordinary foundations like isolated footings or combined footings, though in green projects there is no meaning of combined footings, and also in major projects which are brown one even, where vast areas exist, combined footings are rarely used, or if used, they are used in different way, maybe that's different matter here. But piling can be used, you can say raft can be used, and you can say we can include raft, we can include piles, or we can include beams. There are so many civil engineering design methods, design foundation methods which are used. That's not criteria. Criteria is quality requirement. So design, what is done is done. How we have to do is engineer has to do design. That is important part. But soil investigation must have been done, and soil investigation is very much important part in engineering. Soil investigation, which nobody can deny, that you can say is heart of soil. That is, you can say how to know about properties of soil stratification, you can say, means layers below ground level. Up to what depth is one layer? Up to more than that, because soil cannot be uniform, it is natural. Every meter depth, every half meter depth, it may vary. It may vary in composition, it may vary in constitution, it may vary in properties, it may vary in water content, it may vary in gradation, it may vary in fine, it can vary whatever it is. Means you can find clay soil, you can find silt soil, you can find combination of that. You can find soil, sand, you can find limestone, you can find peat, you can find whatever you do not know. But you have to know, and that information we can get through soil investigation activity, which is conducted by material testing laboratories, which are approved and consistent and very competent bodies for this purpose. Material testing laboratory. So we can say soil is fundamental material. It's not to be purchased, it is existing, it exists every time. On that project you do, the soil existence properties must be known. If we do not know that property, we cannot understand our soil below ground properties of that, and we cannot decide what foundation we have to provide. Foundation is very important part, you can say extremely important part of all projects all over the world. If we do not understand foundation, if you don't understand soil below that, we can't say this project which you have done is going to be safe. There's no way we can do that without providing reliable foundation, and reliable foundation depends on behavior or conduct of soil on which this foundation transfers its load. Load dispersion goes to soil. So soil is very important material in construction, in industrialization, everywhere. Without soil, nothing happens. Just like without soil also has a quality, though it's inbuilt quality, it's not induced quality. It's natural. It takes its quality on its own, which depends on nature, which depends on its history, what history that level is. It's volcanic, or it is sedimentary, or it's metamorphic, or it's different. These rock systems. What type of rocks are they? We have igneous rocks, we have sedimentary rocks, we have metamorphic rocks. These are three basic rocks we have, and there are different like clay stone, siltstone, combination of these. We have all these. We should understand them, and all this goes to detailed understanding, which is technical part, which is engineering part, but which is quality part as well, because we can decide something based on components, based on constitution, based on composition of that natural material. It is mixed up nature and it has been consolidated. It was, undisturbed, but we disturb this by excavation. We disturb everything for time being. It will regain its position after a long time. It may be consolidated back after a few years if it's cohesive soil, you can say. Cohesive soil means like clay soil or silt, or there may be minerals like that, which Mount Morillonite, or you can say, Mount Morillonite is very expensive mineral. Kaolinite is there, so we have to be very careful about those. And what are their properties we should know, which only laboratory can tell us if we ask them for chemical or mineral analysis. So we have to think that way. This list which I'm showing has so much in this, which doesn't give complete information, but considerable information for excavation. As I'm discussing, so much is involved. We have to relate to so many soil reports. We have to relate to descriptions of those, history of that area. If we do not know, means excavation is affected by soil investigation report. Excavation is affected, design of foundation is affected, electrical property of soil tells us something, thermal resistance, thermal conductance properties of soil tell us something, water content of soil tell us something. Same way, graded, you know, grading curve tells something, or you may say water table also tells something. Engineers know it. Technical words are there, technical articles are there, technical definitions are there, which relate to soil. And soil is dominating word as far as structure is concerned. Whatever structure, whatever, everything goes to soil. Nothing moves in air. Nothing moves in air. It may be airport, it may be runway, it may be metro, it may be dam, even sewer line, water line, housing, whatever you say, everyone depends on soil. So soil inbit quality by nature or its natural formation speaks a lot, which we have to understand. This is very basic. Then we have to think of formation, where we have to cite our building foundation. Formation means where we release our foundation to sleep there, to stay there forever on some level, which we call formation. And then formation level allows us to do further activities. That could be unevenness removal activity called blinding, because formation is not in one profile, it has varying profile, but hard one. But we have to then convert it to our working profile by doing blinding layer, and which is concrete one, which must be protected from soil infection, you can say. I should say infection now, though it is not infection, chemical input is there. So there may be chemical impact on concrete or on foundation from soil chemicals, sulfates, many others. This may impact on foundations. There may be water in that, water soil combination mobility, means if there is water which moves in soil for decades, it doesn't move like river, but it moves like moisture. It moves in a form that you can say very very laminar flow it can move in, and it can reach to our foundation, or from our foundation it may go to somewhere else also. So there is no definite answer to that. We generally call it water soil mobility or soil water mobility, which is not easy to be understood. by everybody, because imaginary water, moisture water, suspension water, capillary water, wherever it is, this time comes when it changes its levels because of rise in water table or drop in water table, depending upon time of rain, month of rain, moisture content, position of water. So, as much as water comes in contact with soil, whatever type of soil, soil loses its strength, and when water is receded, it goes down, then it regains its strength after drying. This is usual practice for some soils, not all soils. For example, clay, which swells in while coming in contact with water and swells by many hundred percentages and then goes back later on. But it doesn't happen to that level in case of sand, which shows bulking while coming in contact with water, but at some percentage water recedes out, and say up to 20% water content, it goes back to its original level. So that's what I say. We have to understand how to protect our concrete, because concrete is foundation and it can be damaged by chemicals. For that purpose, we protect it by whatever method, application of membranes, bituminous membranes, or chemical methods, or whatever methods we adopt. That is design issue, performance issue, and then we can say we produce foundations on them. We have to we have to protect those waterproofing membranes as well, because after all, that's also chemical one, and that can be damaged in due time, and that can be affected by chemical extracted from soil. For that purpose, we have to protect that membrane layer, which may be horizontal or which may be vertically placed. We have to protect something on horizontal layer by putting in some layer of mortar, or mortar screed you may call it, mortar layer you may call it. What is generally what is used as a screed, mortar screed, a very thin, say 20 mm or 25 mm thick all over horizontal surface, because we have to work with steel also, steel reinforcement, and also on vertical surfaces we do some other kind of flexible membrane, flexible sheet, or some compressed fiber membrane, whatever we can say it, or we do some masonry work on that, on that you know this on that vertical application on concrete is membrane, and that membrane it remains inserted or remains within this protective wall and surface of RCC. This depends on how we are going to do that. Some people do foolishness also by first constructing that block masonry or brick wall and then doing foundation within, which is reverse process. No meaning at all. Purpose is defeated for what we wanted to do that. Waterproofing, there's no purpose remains, because they don't understand technology. They understand mechanism only, but just for their convenience they do it, and which is not accepted. Then we can say footings, foundations, or whatever you do, there's a process for that, mechanism for that. We know we have defined everything. Items are measured, formwork, steel fixing, and some inserts if there are. These are major items used in RCC. We have to design foundation, and design means formwork size, you can say dimension of footing, thickness of footing, and what dia of steel with what spacing we have to place in both horizontal and vertical arrangements. That is major design. Then we have to take care of these covers, specifically covers of concrete we have to use for supporting steel, putting in position that there should be enough free concrete around steel. Free concrete, which call thickness of covers, thickness of spacers, so that steel reinforcing bars remains inside concrete forever. And different thicknesses of concretes are given, which can be more also, and these are very few items only. In foundation, generally 50 mm and to 75 mm maybe in many cases. 50 is very normal, 50 below footing, on sides of footing, on top of footings, and on step columns sometimes also, and on, you can say, columns above ground columns, it may be 40 45 while for beams it may be 30 35 depending, and slabs may be 20 25 We can increase this to some extent from safety viewpoint, keeping abreast impacts of future accidental effects like, you can say, moisture ingress, like thermal energy ingress by fire. So many points are there which are design issues. That's the reason we have to think of them, and that's the reason we have to explain is why do we need covers, why do we need spaces. They are called covers, we can call them covers also. And then you can say we have to do column work after footings are over. We have to do small columns or step columns below ground which are embedded in soil up to that level, which are columns part but below ground, and it cannot be done through upper part. So we do in ground, then we do work of beams if any there around foundations, and then all waterproofing application or concrete protection applications are conducted or done, and protection of that is done also before going to do soil backfill activity. And that backfill is very important from engineering point of view, because it's not same fill that we excavated, it's different material. Either we import from somewhere else or we prepare that material after screening through shovel and removing all organic materials from that soil, and use design of soil backfill formula. For this purpose we get some other better soil mixed with it and make it ready for purpose of backfill. If it's not very harmful material, if it's harmful like clay, silt, we should not use that. But say it is sandy, for example, we can use it after changing or after designing its new grading. So backfill can be done, which is very very beautiful item, because backfill is for permanent use. Your backfill means your foundation will be stable, you can say a floor will be stable. Backfill is that kind of activity, and it's not random activity, it's very much important activity, not from rate point of view but from performance point of view. Backfill, people don't understand meaning of backfill. This simply is a backfill and put water into done. But backfill is a structured activity, I can say. It's much more important than structure, because it is done below ground, it's done in ground, and it holds resistance to some extent to overturning. It holds, it creates grip, which we don't consider in design. So backfill is a bonus item. It's, you can say, item that helps the structure to be more stable. So don't consider backfill as useless item. I talk to many people, they don't know meaning of that. And some people see, they don't understand that clay is very dangerous from this point of view, but they fill in that. Or see, it's automatically done. They think they fill in and just put water, it's done. So it's not fault of people, I say, it's fault of engineering profession. It's fault of engineers. They do not educate public what is right and what's wrong. And in fact, they themselves don't enrich also about these properties, which is very important. So you can say backfill works. Yes, I mean this work is utmost important. Different kinds, different classes of backfill available. Ordinary backfill, engineered backfill, desert backfill, sand backfill. You can say name one, or you may say, if you understand meaning of backfill, if you understand soil, only then you can clearly understand meaning of backfill. Its backfill doesn't mean same material. Backfill can be any material, can be whatever material. It can be sand alone, it can be imported soil if it meets requirements of our design meets requirements of 98% compaction, field density. Sometimes we use even get more than 100%. You may be surprised with that, but it happens. We may get 90%, sometimes 95%, sometimes depends on which area you are doing backfill. In structural backfill, 98% proctor value is very important. It's considered. If we don't get that, we don't do right. So that is backfill work. Then we can say after backfill is over, we have to prepare grade work. Grade means plinth level and ground level. Plinth level may be called grade level, where you have to prepare for, you have to work for ground floor. Ground floor, it's not a structural floor, it's little floating one. Means if it is not if there's no basement, I'm talking in that case. If there is a basement, then it can't be floating one, it has to be a structural slab. So when I say grade slab, means slab between peripheral area and no structural connection to beams, but it rests directly on backfill. Rests directly on backfill that we do, and its purpose is to carry floor use. It's not going to take any structural force. It's only slab one level or zero level, you may call it, or plinth level. That is called grade slab, which is used in every advanced buildings. Maybe in some people don't use it because they don't understand this. Then you can say we start from there. Above ground structures, above ground columns, beams, slabs, which is named elements in framing, structural framing. Portal frame we call, or whatever frame we call, means where multi-story or ordinary buildings are there. We raise columns and then we raise beams and slabs. Columns works are very important because it is column that is understood to transfer loads to foundation. And then there are beams and slabs in mode of monolithic casting. Slabs, which we'll call slabs, or suspended slabs, also called plates in design terms. Diaphragms, you may say, these you may call for purpose of horizontal resistance during earthquake or during wind effect. This is very important element of structure, and it also takes load, direct load from use, and that load is converted to, that load transfers through slab areas to monolithic cast beams, which transfer those forces to columns. So moments and loads are transferred from slab to beams, and these are further created bending moments and forces transferred to from beams to columns, and same columns to foundations and foundations to soil below. That is mechanism in every structure. It may be columns or it may be walls. It doesn't matter. After all, structure is a structure. So columns are very important in that way. Column which transfers bending moment, direct load to foundations, is designed very accurately, very correctly, absolutely correctly, because if column fails, you can say every part of structure fails. If column goes beyond failure, nothing can save it. Nothing. No material can, no member can save it. Slab will certainly fall. It will collapse. So we have to see that RCC column, how it is done, how it should be done. Then well, walls, lifts are there in every building. Walls to exist in every building. We have to take care of those walls, lift wells, everything. Walls, and then we have to think of staircase, how stair works. Stair is also a structural member of a building. It allows vertical movement in a building using inclined route. It's vertical movement. You go up or you come down, you ascend or you descend. It's all vertical movement, but not direct movement like column. You have to move diagonally depending on dimension of and riser and track. Movement, physical movement is angle one, is in that waist angle, but resulting movement is vertical axis, vertical range, vertical coverage. So that is called staircase, which is very important item, and it can result in tiring also if it's not properly designed. So we have to think of that work also, how it works, how comfortable it should be. Yes, it depends on space available, that's okay, but if you have space, you should not squeeze your stair. You should have comfortable movement staircase, because it will impinge your life with you're tired while walking on stair. Then you can say suspended slab. I call suspended slab because all slabs are in suspension. No slab is resting. No slab rests. No slab rests. Suspension means these are supported on edges and middle portion remains suspended except grade slab. Slab of reservoir tank, slab of septic tank or containment, slab of your room, slab of whole floor. You may say whatever slab, I don't know why name slab isn't given, but slab name is there. It works. It when load comes onto this, and due to its own load itself, it sags. Maybe everybody cannot imagine that what is sagging, or it comes down at certain points from existing one when load is applied. We have to provide resistance to that suspension sag, and that suspension sag or deflection is controlled by many ways, by providing required thickness to slab, and also by providing steel reinforcement within slab wherever that is required. And then load comes onto this, load works on this, it should remain stable. It should not, if it sags or deflects, when that extra load is removed, it should recover back its sag, and it should recover fully. That's called design. If it doesn't recover fully, there's left something permanently, and that's called deflection. And that deflection should be within limits as well. But why? By designing properly its sizes, its thickness, etc., and beams around, we can say we have deflection controls. We can use that. That's purpose of this. And then there are other footings. You can say pedestal footing or machine foundations. You can say those footings are structural steel members. They are footings, as well as all footings, whatever combined footing, other footing. There are so many types of footings. And then we can say machine foundations, very important. That's also in buildings, commercial buildings, industrial buildings. Various types of, you can say, reciprocating machines, vibratory machines are installed in industries and factories, for which we have to decide we have to do. I've just given some examples only for generator and alternate foundation. And we have to think of structures which are having not going to be plastered or rendered. We have to think of tacos, structural works, structural items, and also architectural finishes which do not need any plastering on them or rendering on them. These are well decorated, attractive finishes. Then there are different types of slabs used some Middle East or somewhere else. It's called Hurdi slab, where whole slab surface below there's no beams. There are no visible beams, down stands, clear, you can say, clear slab without any obstruction. We call it Hurdi blocks, based slab. Then sloping portions of sloping portions of slabs wherever we use small or big. We use sloping angle angles located slab profile is sloping. How to do that? What should be angle up to it can be without double form on slab, or where top form is also required. About that talk. And after that we have general slope, and then machine foundations, compressor foundations used in plants, which is very important item. We can't do that without, we can't go without that. If those are not available, those are not done, plant cannot move. These are having different structures. When we solve compressor foundation, it doesn't mean below ground only. It means mounting, a kind of mounting. We say when it's a machine foundation like compressor foundation, it's a kind of mounting on which we place our machine, vibratory machine. And that mounting is, there are certain structures in the mounting, and that, if you say, a level structure on which you directly place your machine plates and balls, it directly rests on that. That's called framing or top of that mounting. We can say, when you name it tabletop, means there's a table on which there's a table on which there's a base on that. There's a base, there's a table, there's a base, and we put that engine, that machine, on that base. We put that machine on that base, and that is called top, we can say. Is tabletop. Whole structure is a table. You may say that there are various elements, components in that table. One is top, one is vertical structure, columns, and below columns is foundation. Phenomenon is same. It's not different. It's tabletop, we say. Tabletop, top on which that's a kind of framing, a beam framing on which our engine or machine rests. That's supported by columns, thick columns, and they are further supported by massive block. We say massive block in this case. There could be some other designs like springs or frame foundation as well. It's not necessarily a massive block, but because we are taking massive block due to reason of weight of machine or performance of machine, we have to control amplitude, we have to control movement, we have to dampen vibrations, transfer from machine, we have to isolate those vibration, those impact forces. Those impactable forces are to be isolated from impacting real foundation in touch with soil. That is important point we have to consider, and that's why we call it tabletop or compressor foundation or machine foundation. Top is an element, middle is column, and bottom is foundation. That's what they call it. Then it's very important because weight of this foundation is quite considerable. I still remember a case when it was 400 cubic meter of concrete, which means about 1000 tons weight of foundation. This 1000 tons weight of foundation can utilize the effect of impact forces transferable or transferred from that machine. That's sole purpose. And then we can say such units are very big, very expensive, and such units require major quality controls, quality input. These can be called, there's many serious quality checks on them. That's what we have to perform with, we have to think of. It's very important one. Then we can say there may be, let us say, below ground waterworks, water reservoirs like swimming pool. It's not reservoir actually, but let us say water container. We can use in swimming pools, and also we have dry works like shooting ranges. As I said, if we consider case of swimming pool, it is a water structure, water retaining structures, and there's circulatory motion of water from this pool. In this we have to jump down, we have to climb down, dive it, and also water is in motion here. when people use when people use swimming pool, water remains in motion. When people use, and when people don't use it, it's locked, it's closed, it remains stand still. So they are both positions, and we have to take care of concrete element that contains this water because of water tightness is required for that. Structural adequacy is also required, water tightness is required, and durability of concrete is required. So many points are there that are design issues, but also quality issues. So we can say that below ground RCC swimming pool works and firing or shooting range is very important. Firing, though, is specialized work. It is used for those people who work in defense forces, training for armed personnel, which is very important. And this could be to any range. I dealt with one building that allowed me, that apportioned me with 300 meters net range of shooting. Net range was 300 meters. And this white one means so long structure you have to build. So long structure means 300 meters means you have to construct walls on both sides for completing that range. And there are other ways, means buildings are the shooting is the dampening effect should be there at bullet trap, we call it bullet trap chamber. There are many subways cross like that. It's huge structure, huge quantity of concrete. And there's very small item like light poles, you can say, light poles on streets, light poles on roads, light poles which are about 12 meters high, somewhere it's 8 meters high, and you can see same in sports stadiums also quite high. So those poles are also very small item but useful, important. And then we can say you have to think of all these pores. It's not preparatory works we talk of. We have to talk of complete pouring of these, which is also very important point from construction of that. So pouring is ultimate game. Pouring is ultimate target. We have to achieve that pouring, and if we don't achieve pouring, all preparatory works are useless. We can't keep them forever. Okay, we will pour later, let them be there. We can't say that. We have to pour them, and not only pour them. After pouring, we have to remove formwork. Steel can't be removed, but formwork is to be removed. So formwork is a preparatory item. Placing of steel is permanent item. Placing of pouring or concrete is permanent item. We have to analyze that way. Formwork is preparatory work. Scaffolding or access to that formwork is temporary work. Scaffolding below form or slab is temporary system to support that. Formwork fixing is preparatory work. Steel placement is preparatory work, but steel is permanent. Concrete pour is permanent. We have to streamline like that. It's very important one. We can't go otherwise. So I'm just showing a list, which is very important one. In this, I am trying to explain procedure that goes into all items. I explain to you one by one, and also I'm charting more items which are very close to each other, but you can see these are all pouring, pouring, pouring list. Then all items are here in this. Now I like to go to, you may say, at some other point. That is some water reservoir project, which is a different one. I'll show you these sketches as well. Sketches, which was actually a part of some project. I just want to have some word on that. That's one water transmission. That's a water reservoir. Actually, it is water reservoir. How can we do that, and what checks are there? It's a kind of method statement, a sample where quality checks are involved. This is definitely quality requirement, house plan method sketch. Let's go to inside itself better rather than staying there. So my folder is here, and this is our, I may say, oh yeah, come on. Oh, come on, yeah. Why it's not shifting away? It's a problem here, It's a problem always. Yeah, it's gone now. Water pumping, no, it's not water pumping, it's something else. It's not that one. Water reservoir, yes, it's here. And it's here as well as it's here. You'll find this sketch here very clear to you. It's here, and other one that should be here as well. Let me see. This two is here, both are here. Now why I'm trying to show, nothing to do direct way, it is a structure of this building. This is a reservoir. Actually this was designed somewhere. I got some work of tender for this. I'm just trying to indicatively tell you, share with you. It's not my design, first of all, nothing to do with me, just I had to deal with, I just remember this sketch and I'm trying to share with you information. Size of this tank, it's a big scheme tank. It's an element component, a big scheme. It is, let us say, you can say 130 meters and 15 meters here. It's about 145 meters this way. This is tank portion, 100 meters wide. This is tank portion, and this is, baffle walls here, baffle chamber. It's quite high, 10 meters deep, and this is inlet chamber, and this is outlet chamber. These are very small structures. We compare to water reservoir, only 20 by 20, and this is section of this section here somewhere. This is inlet having some, and RCCTRN, and this is, you can cut out here. This also here. This is another one cut out here, and section like this. Purpose, forget purpose. This is your baffle chamber, and that tank is there. This is all columns located at 5 meters spacing both ways, uniform location for stability of design. That's good one. Location of movement joints is also shown. 4 movement joints in one end and about 4 or 3 on other end. That's okay. Then if you see it's really structural refraction, you'll find in that complete grid, complete axis, dimensions are shown, which you call line plan with column locations. This outlet chamber, this inlet chamber, this water reservoir. Very, very indicative sketch, just for information. And also same was other one as I showed to you. Now what actually I want to discuss here, that is, you know, this is part of transmission scheme, water transmission scheme. So what it says, let us look into that one by one. What it means by that, what it wants to say, that's the important one. It wants to say, it require something. Says, if you see purpose or scope of this writing is what? This is scope of this typical writing. No, purpose of this document is to define construction procedures. Construction procedures which may be adopted for prosecution of typical water reservoirs project. 4 number typical water reservoirs, not 1 number, just keep it. That was only typical, I said. They are going to be installed 4 such reservoirs. 4 number typical water reservoirs proposed to be built at one location. See, size of location then is big one. At one place 4, and one place is 100, around 150 meters. 4 means 2, 1, and you can say 150 meters, then 150, 300 meters by 200 something, by 300 by 250, 300 meters by 250. It's quite a big area to cover in this. Now 4 number typical water reservoirs proposed to be built in one location. This statement is meant only for sharing general description of indicative procedures for various operations involved. Other detailed working typical statements would be produced later during real execution of works for each activity as standard procedures applicable to project duration may be 20 months or variable. This sketch referred to making basis for this work is only for indicative purpose without mandating any authenticity. Quantities mentioned are also indicative just to explain method. Now, period for tank construction could be 14 months. 2 tanks planned to be constructed simultaneously. Safety requirements and quality procedures requirements to be defined separately on individual activity operation basis. Sometimes what happens when projects are very specialized. While doing your bidding, a question comes, it give method statement or execution statement. We want to know contractor's competency, contractor's awareness, means what does contractor understand, EPC contractor understand by this proposal. Is that contractor capable of comprehending this? We want to ensure by certain writing statement, certain written statement, that is called method statement, and that should be given indicatively, means not mastered one, but you can say in a way you can understand this, you can do this. Means you have a capacity to do this. That capacity establishment, that capacity building is done by such inclusion on kind of documents of this type of statements, which I did myself. I was a part of that team. So though I made changes to that one in this statement, because this is very old work. I think this was done somewhere in 2007. Let's say 2007, 14 years back. So what I did that time, what was requirement, I did that one. But now I'm putting in my additional input into this, and which is very much required. So you can say in this case, reference documents, of course, integrate, and these are drawings for project schedule. Project drawing schedule is there, and these drawings come from that. Reference attached from vendor's homework, which not included here, but there are some references. Then general arrangement, walls and columns, top certain designations of those from vendor, which is not included. Then there are certain tables, vendor references, which also not included. A specification for concrete reference to be indicated, whatever source being used. In your case, you can use your own references. Here we used other one. Specification for concrete reservoirs, reference to be indicated from whatever source being used. Attachment drawing is just for indicative information. It should be a part of contract drawing documents. Now something about design. Prior to construction of reservoir, all proposed form systems shall be designed to meet final requirements, and calculations with shop working drawings be submitted for approval. Construction execution of reservoir RCC structures shall be shall be charted out based on approved for construction drawings, which should abbreviate AFC. All working construction method statements be charted out for approval in compliance. Existing services. Records shall be checked for possibilities of certain underlying running services as a matter of routine. As such, activity may be a part of regulations. Existing services, if so located, shall be informed to relevant authorities as well as company for necessary actions. Trial pits shall also be excavated to scan whether or not certain service exists. In case certain live services do exist, all actions shall be taken to either protect such service or divert permanently per authority's direction, or as case may be, authority would do itself if construction or EPC contract does not include such provisions. Supervision and control. Construction leader, site engineer, construction foreman, and charge hands shall control all activities on site given to them according to relevant job description indicatively included on project plan. But construction leader and relevant site engineer are four located officers, four located controllers for all activities. What we do now, we say survey controls. Survey controls. According to AFC drawing, you can see these drawings I'm talking. There are only 2 drawings here, but there are many more which we have not taken into our consideration. I could remember what I did that. According to approved for construction drawings, surveying team shall locate setting outlines, coordinates as well as surrounding circulation area for construction purpose. Since dimension of built up main reservoir are given around 130 meter into 100 meter, adequate arrangement shall be made to carry out mass excavation works. All topographical levels shall be recorded for reference to be used in future. Site shall be graded to reach required ground level. All survey documents shall be prepared for purpose of verification. Around area Guide barricades shall be erected for purpose of locating grids and reference site levels. Benchmarks shall be established on all corners for purpose of flying and re-establishing all working locations. Establishment of base corners points as well as base level benchmarks shall be conducted by licensed land surveyor whose documents submitted to engineer for approvals and records references, or third party may be involved for establishing site references from GPS for both horizontal and vertical controls. Safety, Health and Environment (SHE). All safety measures shall be resorted to per safety plan according to excavation's requirements. Warning tapes, safety cones shall be provided around defined working areas. All safety and direction flow signboards meant for excavation safety shall be provided and remain in position till excavation continues. All dangers or hazards from such trenching have been eliminated. Warning light, warning night lights, reflectors shall be provided around for public safety. Aluminum ladders shall be provided duly clamped for access into working areas, located not more than 8 meters spacing on all trench sites. Working and pouring stable platforms for people, personnel to work safely shall be constructed, installed. For convenient access of heavy equipment into formation areas, ramps shall be provided from existing or grade formed level from two opposite ends, if so required per site conditions, as well as from soil report. Rewatering arrangements shall be carried out continuously until construction reaches roof slab level or retaining walls and baffle walls have been constructed. Toolbox stocks shall be imparted daily for all important operations involved. A safety officer shall inspect works every day during all concreting activities, form erection activities, and all traffic movement activities, etc. Materials. Concrete source. Ready-mix concrete. Ready-mix concrete from an on this project approved supplier shall be procured. Reinforcing bars shall be procured from an on this project approved source only. Reinforcing bars shall be fabricated in steel yard located elsewhere on site. If on site steel yard installation is acceptable, it shall be included on site establishment plan and duly approved. All fabricated bars shall be tagged according to BBS bar bending schedule references. All fabrication or cut or bent bars shall be stored, duly tagged and covered properly so as not to permit any moisture ingress on rebars surfaces. No rebar shall be placed on soil, but adequate off-ground safe platform be constructed for storage. Form fabrication. Only suitable machines and power tools shall be used to cut and fabricate forming materials. Fabrication of plywood forms shall be carried out on site based on specialist formwork vendor details. Supporting detail system shall be provided by formwork vendor based on detailed design approved by engineer. On-site formworks shall be erected according to complying with vendor's drawings. Scope of vendor formwork system. The scope of vendor formwork system shall be confined to retaining walls, baffle walls, columns, flat slabs. Procedures method for one reservoir construction. We are giving here one reservoir, there are four reservoirs, so we cannot give same thing four times. Okay, so what's that? Summary of pre-RCC structural preparation activities for one unit set of reservoir. General activities prior to structural construction are as indicated below for guidance only. 300 mm compacted granular subbase laying on all areas, which are what areas? 135 into 105 meter, 25 into 25 meter, another 25 into 25 meter, which all come to 15,425 square meter, or when you take it 0.3 meter thickness, it becomes 4,628 cubic meter. $75 mm concrete blinding laying on required area, which is around 1094 cubic meter. Second, because the two number layers bituminous membrane horizontal application for concrete protection below ground, that is 15,425 square meter. 50 mm screed to be laid for protecting horizontal protection. Membrane is 15,000 square meter. And we can say application of vertical protection. We can say here also 50 mm screed to be laid for protecting horizontal protection membrane, which is 15,000 square meter. Application for vertical protection membrane around below ground, which is 2176 square meter. Structural construction activities. Structural construction activities for designs quantities not worked out. The component elements involved to be constructed are indicatively given below. One is RCC periphery retaining walls around. Of course, these are 10 meters high. RCC periphery retaining walls around. RCC base slab through entire area of water reservoir. RCC baffle walls for baffle chamber. Construction joints in RCC for design requirements. Expansion joints in RCC for design requirements. Then RCC columns with heads below flat slab. RCC suspended slab throughout. All components pertaining to adjacent inlet and outlet chambers. Components of overflow chambers. Then we can say all components pertaining to adjacent inlet and outlet chambers, components of overflow chambers, RCC intermediate suspended slabs, RCC walls per designs. These are elements, RCC sump pit elements per designs, box outs wherever required or indicated, stair structure as indicated on drawing, whether RCC or structural steel, RCC roof of stands, above ground concrete protection around. General activities post structural construction, filling PVC pipes inserts, within walls where with approved proprietary material, fixing of manhole covers and frames on reservoir roof, roofing and waterproofing per standard approved system, roof handrails around over upstands per details, external walls pattern formation, 12 mm white interlocking paving around reservoir construction. Detailed activities prior to structural construction, excavation and subgrade. After clearance from engineer, excavation shall be started using heavy equipment, removing excavated material from site location, loading excavated material directly into truck and transporting to tip-off stockpiles, or in case material could not be used for backfilling purpose, probably transported to a designated dumping area. This is nonsense. Who is this? I don't know. People disturb for nothing. What I do with this? They also help with this. I forgot to do after clearance from engineer. See, God, what I did. After clearance from engineer, excavation shall be started using heavy equipment, removing excavated material from site location, loading excavated material directly into truck and transporting to tip-off stockpiles, or in case material could not be used for backfilling purpose, probably transported to a designated dumping area. Metal that is stockpiled can be sorted out for backfilling purpose using screen fixed shovel, and later, if laboratory recommends, based on full range testing, design mix of additional material, namely graded soil or some other material in given proportion, could be mixed to obtain well defined combined grading to get demanded or suitable FDD to avoid imported fill material. During excavation, dust control measures shall be carried out or applied by conventional means for purpose to avoid environment hazards. Excavation shall be carried out approximately to excavation shall be carried out approximately to formation subgrade level only, all complying with profile shown on approved drawings. Land surveyor shall continuously control levels so as to avoid over excavation. Excavated formation shall be dressed manually. Excavated formation shall be dressed manually as well as using light rollers, and after formation profile is established, heavy rolling shall be carried out over entire area to reach field compaction to 90% to 98% of dry density. Field compaction tests shall be conducted complying with standards and specification requirements. Quality engineer shall inspect profile for clearance and approval. 300 thick compacted granular subbase. First layer of subbase shall be laid loose in 200 thickness, well watered per requirements and rolled over for an objective to achieve 150 compacted thickness. Profile of subbase shall be given according to details which indicates a fall in 1 in 500. After rolling, loose laid material shall be compacted to 150 thickness in this course. Site FDD, field density, field dry density testing shall be conducted from this layer in conformance to specification requirement for granular subbase spread over entire area. Thereafter, second subbase course construction shall be carried out, for which scarifying of previous laid first compacted layer shall be carried out for interlocking bonding between first and second compacted layer. Second 200 loose shall be laid over scarified surface and well watered. After rolling, loose land material second layer of 200 thickness shall be compacted to 150 thickness in this course as well. Profile of subbase shall be given according to details which indicates a fall in 1 in 500. Site FDD testing shall be conducted from this layer in conformance to specification requirement for granular subbase spread over entire area. (75 thick concrete blinding and mass concrete requirement). Blinding shall be done in stages parallel to width of reservoir. Blinding shall be done in stages parallel to width of reservoir. Hole blinding shall be divided into 6 to 8 bays, each 20 or 25 meter wide and 100 meter long. One stage blinding quantifies to about 200 cubic meter, which is feasible for a convenient casting. If so required for ease of convenience, further formation of bayed compartments could be established within each bay for alternatively placing blind in concrete. Low profile strip formwork for controlling site shall be prepared and fixed. A concrete laying team shall be grouped for this purpose, such that concrete received from transit mixer is immediately pumped into location and spread using teeth shovel. Proper leveling shall be carried out using wooden float edged by masons. Whole area shall be laid profile to 2 levels and given wooden float after concrete is ready to receive wooden float. Polythene sheet shall be spread over entire area immediately. Routine curing procedure shall be complied with per agreed procedures. Curing shall be carried out for 3 days only. Before laying new concrete at set edge of previous blinding at edge, cement slurry shall be applied to edge so that new and old concrete is properly bonded. Mass concrete shall be carried out as shown on approved contract drawing. Whatever depth being more than 75 shall be blinded only For no backfill is permitted on approved subgrade. Two-layer bituminous membrane. At end of curing, surface shall be cleaned of all dust and dirt particles, all debris, water, etc. inspected. Blinded surface should be smooth enough to receive bituminous membrane application. All cracks appearing on certain damaged portion, wherever located, shall be repaired either by grouting or by breaking and relaying concrete. According to manufacturer's instruction, bituminous membrane shall be applied over blinded surface in both sheath applications. 50 mm thick screed for membrane protection. Membrane shall be protected by an application of 50 mm thick screed layer as soon as possible and cured accordingly by repetition of foregoing activities in sequence but in alternate basis. Construction of peripheral retaining walls, major elements. Preparatory works for one corner L shape, one set, 4 stages in repetition, limited height, refer to attached sketches. Preparatory works for straight wall 1 set 35 meter long, 1 set 30 meter long, 3 repetitions each, limited height. These elements comprise of base slab, shear key and upright RCC structures. Shear key is not indicated on sketch but may be required. Preparatory works for base slab, non-proprietary formwork. 26 by 20 is 520 repetitions of each way. Uh, 520 repetitions of each bay. Each bay comprises of 4 sides as indicated on typical square on sketch. Side fabricated forms to be used. Water bar sides to be prepared for construction joints in horizontal position. Fabrication by fusion welding of construction joint. Related water bars to be carried out. This activity shall be affected for all horizontal slab base. This activity shall be affected for all horizontal slab base. Since such fusion welding is difficult task, bars can be laid in straight line, passing all bays in one direction, and then fusion application conducted on crossbars sections as an alternative. Arrangement of reinforcing bars to be made through vertical forms correctly, for which purpose lost or sacrificial forms work could be installed in helves all around base. Fabrication by fusion welding of construction joint related water bars to be carried out. This activity shall be effected for all horizontal slab bays. Since such fusion welding is a difficult task, bars can be laid in straight in line, passing all bays in one direction, and then fusion application conducted on crossbar sections as an alternative. Arrangement of reinforcing bars to be made to pass through vertical forms correctly, for which purpose last or sacrificial formworks could be installed in halves in all round layers, all round base. Preparatory works for columns, proprietary formwork. As explained last in this column base, this is column base, base slab base, these four sides as reflected here in this. You have to provide water bars, and these water bars can continue like this, continue like this, and this can you can say in crosswise. This way you can do. There can be, you know, permanent form here, a vertical, through which half above and half below these base concrete can go in. And again, these are individual base, alternative base. You can pour in according to that system. And this is most important point. We can continue like this. It's up to you. I want to make separately, you can make separately. You can make straight also, and then crosswise you can weld. That's what it is about. So it depends on your working conditions. Now we are talking of columns. I have 85 sets of column for 475 columns costing 5 6 repetitions, each using marine plywood. Each column comprises of 4 sides. Of course, it is 4 minimum. Working drawings for formwork to be designed, keeping in view single pour for full height. Site fabricated forms shall be used to standard designs or in compliance to vendors' designs as suitable. Vendor standard formworks may also be used for this activity. Preparatory works for baffle walls. Proprietary formwork. 4 separations refer to attached sketch. Both sides of each wall shall be prepared for forms either from vendor source or by site fabrication source. Preparatory works for inlet outlet chamber as well as overflow. One set 2 repetitions. This comprise of what? This comprise of many activities. Now that's important list here. What this list is: excavation, inlet and outlet chambers I'm talking, which list comprises of there are one inlet and one outlet. There are 2 chambers, and activities included are here: excavation, soil improvement or subgrade, blinding concrete layer, concrete protection membrane, screed cover, foundation beams, stub columns, stub walls, grade slab, sump walls, base slab, walls, columns, cantilever slabs, suspended slabs, external suspended slabs for connection, stairs, handrails, roofing, concrete protection above ground, backfill, external paving, etc. I repeat: excavation, soil improvements, upgrade, blinding concrete layer, concrete protection membrane, screed cover, foundation beams, stub columns, stub walls, grade slab, sump walls, base slab, walls, columns, cantilever slabs, suspended slabs, external suspended slabs for connection, stairs, handrails, roofing, concrete protection above ground, backfill, external paving, etc. Preparatory works for suspended slab, proprietary formwork, 1 set 2 repetitions, flat slab construction. This is a very important point here that we cannot complete today. It's L shape. One wall is L shape. Corner of reservoir at that location. Setting out of each, we can say it is somewhere here. We take it here in this consideration. We take here in this consideration somewhere here. It's L shape and it's somewhere here. I think this structure I've shown. It should be somewhere here. One here, one other one. One is down, another one is a fall. This will be, I don't know all trying, so I can't explain clearly. It should be setting out for each L-shaped wall at corner, shall be carried out on screed for base slab, toe and heel portion of retaining wall, toe and heel portion of retaining wall. Reinforcing bars shall be placed according to details provided with supported on due spacers. Steel bars fabricated chairs be provided between top and bottom rebar layers. At end of everyday work, polythene membrane shall be spread over, placed and fixed on reinforcing bars for protection from humidity. Vertical forms shall be prepared at site using plywood and wooden battens, all in line approved methods. Arrangement for construction joint shall be made for insertion of approved water bar so that lower half of bar is inserted in retaining walls. Base slab concrete. Retaining wall base slab shall run continuous without forming any construction joint. It shall be ensured that set lines of forms are in true alignment and plumb. All vertical sides shall be very well supported so that 1 meter high concrete pressure is sustained by supporting system adequately without concrete bulging. After clearance by site engineer. After clearance by site engineer, whose inspection shall be conducted and engineer's approval obtained for pouring concrete. About 600 cubic meter of pour in this program that may take about 16 hours. Pouring shall be done in 3 layers so that cold joints are avoided. 2 concrete mobile pumps shall be used for conducting this pour. Concrete delivery shall be maintained continuous. Portion of green concrete at wall junction shall be roughened before concrete is hardened. Exposed portion of concrete shall be properly finished to defined levels and immediate instant as well as specified duration curing be continuously carried out. Following preparatory works for upper wall portions shall be continued. Upright walls. Scaffolding shall be erected on both sides for accessing workers to fix reinforcing bars and erect formworks for upright wall. Reinforcing bars shall be placed properly in compliance with design details and engineer's approval obtained prior to closure of forms. At end of everyday work, polythene membrane shall be spread over, placed and fixed reinforcing bars for protection from humidity. According to formwork vendors' designs, sides of forms shall be erected and fixed. It shall be ensured that erected forms are in true alignment and plumb, as well as outer wall forms comply true to design profile. Anchoring arrangements slaved in for wall to tie bolts shall be fastened properly. All formwork supports as shown on details shall be provided. A working platform shall be built on top for workers' safe access and safe working. Water bar shall be inserted in all vertical positions, duly fusion welded using cross as well as T's wherever required. Permanent bars shall also be inserted as shown on vendor's drawing. Outer forms shall be checked for correctness of related compliance with design profile, while vertical forms for verticality as well as alignment. QC inspection shall be conducted and engineer's approval obtained. QC inspection shall be conducted and engineer's approval obtained. Program shall be charted out for pouring about 250 cubic meter in one go. concrete pouring chute pipes shall be inserted vertically into prepared works so that net drop of concrete is not more than 1.5 meter to 2 meter. Pour shall be carried out in layers not exceeding 400 mm so that vibrator nozzle penetrates successfully internally. This pour shall consume about 10 hours, and at end of pour top surface shall be properly floated and either curing compound instantly sprayed or pour covered with polythene sheet. Side support shall be stuck only after 48 hours.